So this is going to be the angles chapter for my book, Overcoming Digital SAT Math. And if you have a copy of this, as always, I'm going to remind you, do the problems on your own first and attempt corrections on your own first to get the best results, and then kind of use this video as a guide for explanations on stuff where you're stuck. And then also I'll put in the video description of this and like the other chapters, like the description of each of the videos, links to other videos I do over time, or like videos I already have that you might find helpful. So just look out for that in the next couple of weeks after I post this, and like beyond that, because who knows, I might have a video like a year from now that you might find helpful, and then I put it here. So yeah, let's get started. So there's just some notes up there. I go over that in my ACT video, which I'll probably link in this description later on. But let's start with number 1. So it says in the figure above, assume measure of angle A is 30. So we're saying this is 30 degrees, that this is 97 degrees, and that we want to find what's the measure of this guy, what's the measure of angle C. So we know that all the angles in here have to add up to 180 degrees, right? Because a triangle adds up to 180 degrees. So you could just say, oh, that means that this angle has to be 53 degrees because 53 plus 30 plus 97 is 180. And then you say, oh, these add up to a straight line. So C must equal 127 degrees because 180 minus 53 is 127. You could do that. Or there's like some other theorem that's like, I think called like the exterior angle theorem, something like that, which would also tell you that like this is supposed to be equal to like those other angles right there. I think that's what it's called. Hopefully I'm getting the name right. This is just the way I see it, just logically, that it adds up to 180. The straight line adds up to 180, so that has to be 127. Okay, so now pause to read number 2 if you haven't already. So I like to say you can always use just like with these parallel line transversal questions that look like this, you can always just use corresponding and vertical angles to like get around all the other rules, like the same side interior, like all of that. Personally, I don't even memorize those and I never have, because like, why would you do something you don't need to? And I just got really fast at doing this, and I think that this is like a great strategy. So corresponding angles are exactly like what they're named. They correspond, they're equal to each other. So like on each respective parallel line, this is going to be the top left angle, and this is going to be the top left angle. So they correspond, they're in the same spot on their lines, so they also are equal. So just remember, if they're in the same spot on their line in relation to like their parallel line and the transversal, they're both top left, then they're equal. And then you can remember also that that vertical angles are equal. And then that would tell you that this is Z right here, this is equal to Z. And then, you know, these add up to a straight line. That's the other one I use. I use basically vertical angles, corresponding angles, and then supplementary. That these add up to a straight line right here. So they add up to 180 degrees. So 56 plus Z equals 180 degrees. And you'll get like really fast at doing this. Sorry, I have to just do the dot. It bothers me otherwise. You'll get really fast at doing this. Like it's slower now because I'm explaining it. And it's just, in my opinion, way easier than memorizing a bazillion rules and then getting it all mixed up. So now we're going to subtract 56 from each side, and that's going to give me 124 degrees as my answer. So it should be D right there. Okay, so now pause to read number 3. So what I like to do is I like to write in like all the missing information, put like a question mark, sometimes like what the question's asking, so I can just keep track of that. And then I extend out the parallel lines and the transversal so I can see it more clearly. And I'm going to highlight so you can even see like better. So let's focus on this transversal because there's 2 transversals. Let's focus on one at a time. So we're going to focus on this one. Now, if I'm focusing on this transversal, right, and I'm saying, okay, I'm going to look for corresponding angles. This 45-degree angle is bottom right. This angle is bottom right over here on its line. So they have to be equal. And then by vertical angles, this also equals 45. So now I have a triangle right here. And I could say 55 plus 45 plus this angle must add up to 180 because it's the interior angles of a triangle. So that means that this angle must be 80 degrees. And then I know that this angle plus the missing angle that we're solving for in the question add up to a straight line, so they add up to 180 degrees, meaning that the question mark angle right here must equal 100 to add up to 180. Okay, pause to read number 4 if you haven't already. So I put in that 2 is equal to x degrees. I also went ahead and labeled that this angle right here, from here to here, this guy, is basically angle 1. Like they're equal because these are both top left on their respective lines. So I can say that angle 1 plus angle 2 add up to 180 degrees because they add up to a straight line right here. So let's write that out. Measure of angle 1 plus measure of angle 2 equals 180 degrees. Now we want the difference between these. So let's rewrite this in terms of x. So let's say measure of angle 1 plus, instead of measure of angle 2, I'm going to write x is equal to 180 degrees. So now I'm going to get measure of angle 1 by itself by subtracting x from each side. So that's going to give me 180 degrees minus x degrees. So that's equal to measure of angle 1. I already know what measure of angle 2 is equal to. Measure of angle 2 is equal to x degrees. So if I want to subtract them to find the difference, measure of angle 2 minus measure of angle 1 is going to be x degrees minus, and then I'm going to put what measure of angle 1 is. So 180 degrees minus x. So now I'm just going to distribute the negative to each of these terms, and then I'm going to get x minus 180, and then minus a minus is plus, or minus times a minus, I should say, to be more accurate, or negative times a negative, is probably what you guys are used to, is plus x. So now I'm going to combine my like terms. So x plus x is 2x. So I have 2x minus 180. So the answer would be A. Okay, so now pause to read number 5 if you haven't already. And again, let's think corresponding angles. So angle 1 is top left, so it can match this one top left. And then angle 3 is bottom left over here. It can match this one bottom left. Angle 1 plus angle 2, those add up to a straight line. So angle 1 plus angle 2 equal 180 degrees. And same thing with angle 3 and angle 4. If we add them up, we should also get 180 degrees. So if we want the sum of all of these, if we want angle 1 plus angle 2 plus angle 3 plus angle 4, well, we know these are the same thing as 180 degrees. And these are the same thing as 180 degrees. So 180 plus 180 gives us 360 degrees. So B. Pause to read number 6 if you haven't already. So complementary angles are going to be angles that add up to 90 degrees. So that means A plus B has to equal 90 degrees. If we know angle A is 37 degrees, and then we know we have to add angle B to get to 90 degrees, we can set this up as an equation, subtract 37 from each side to get angle B completely by itself. And when you do that, you're going to get 53 degrees for angle B. Okay, pause to read number 7 if you haven't already. So supplementary angles add up to 180 degrees. So that means angle A plus angle B has to equal 180 degrees. So angle A is 125 degrees plus angle B has to equal 180 degrees. So now let's subtract 125 degrees from each side, and that's going to give us that angle B is equal to 55 degrees. Okay, pause to read number 8 if you haven't already. So we want the sum of x and y. So there's two triangles here. There's the big triangle and this little triangle. I'm going to focus on the big triangle first. So the big triangle, I'm going to call this angle Z right here because I'm already using x and y. So I know that all three angles in the big triangle have to add up to 180 degrees. So that means 57 plus 48 plus Z has to equal 180 degrees. So 57 plus 48, that's going to be 105 degrees. So 105 plus Z 105 degrees plus c has to equal 180 degrees. So now let's get z by itself to solve for it. So I'm going to subtract 105 from each side to get z by itself, and I get z is equal to 75 degrees. So now I'm going to label that in my drawing right here, 75 degrees. Now I'm going to focus on the little triangle. I know all three angles in the little triangle have to add up to 180 degrees, so let me write that as an equation. X plus y plus 75 degrees equals 180 degrees. Remember, I want the sum of x plus y, so I'm basically solving for this right here. I can do that by I can isolate that by subtracting 75 from each side to get x plus y by itself. So now I have x plus y is equal to 105 degrees. Okay, pause for number 9 if you haven't already. So for this problem, it's important to remember, and they love doing this on especially the SAT. They do it on the ACT too, but I would say like the SAT is more like well known for this, where they like to kind of trick you with these easier problems and just say, oh, we want you to find the value of all of this, but they're expecting you to just solve for y and think you're done, but they're not asking for y. Remember, pay attention to the question. They're asking for what y minus 2 squared minus 3 squared is. So yes, we do need to solve for y, but then we need to plug it in to get this value. So first, let's solve for y. So these two angles add up to 180 degrees. So I'm going to write that as an equation. So there it is. Now I'm going to combine my like terms of 7y plus y to get 8y. Whoops. 8y minus 12 is equal to 180 degrees. Now I'm going to add 12 to each side to get 8y by itself, and that's going to give me that 8y is equal to 192 degrees. Now I'm going to divide by 8 on each side to get y completely by itself, and that's going to give me this. And I think that actually divides evenly. So yeah, 192, 8 goes into 192. I mean, you could do this in your calculator. I'm just going to do it off here. It actually takes me longer to like take out my calculator, and now I'm describing it and it's taking me longer. So, okay, so 8 goes into 19 2 different times. So then that's going to be 16, and then that's going to be 3, carry down the 2. 8 goes into that 4 times. 4 times 8 is 32. Subtract and you get 0, so it's equal to 24. So we know y is equal to 24. So now I'm just going to plug in 24 for y right there, now that I've figured that out. So it looks like this when all I did was plug in 24 where the y is. So now 24 minus 2, that's going to be 22. So I have 22 squared minus 3 squared. So let's figure out what that is. So that's going to be 484 minus 9. And then when we subtract that, we get 475 as our answer. Okay, pause to read number 10 if you haven't already. So right away, I see vertical angles. So that means they're equal. So angle 1 is equal to angle 3. I also see that angle 2 has to be equal to angle 4 right there, because those are also vertical angles. So let's see. It says for number 1, angle 1 plus angle 4 is equal to angle 2 plus angle 3. So let's write that out. So angle 1 plus angle 4, well, angle 1 is equal to angle 3, so I could replace that with angle 3. Angle 4 is equal to angle 2, so I could replace that with angle 2. So those are equal to each other. So 1 is correct. You can automatically say, okay, it definitely can't be B. Angle 1 plus angle 2 is equal to angle 3 plus angle 4. Well, angle 1 plus angle 2, angle 1 is equal to angle 3, so we could say it's angle 3 plus, and then angle 2 is equal to angle 4, so we could say that angle 2 is equal to angle 4. So yes, this works as well. So now we're just left with picking between C and D. So let's see if number 3 works. So it says if we add up all of the angles, that we're going to get 360 degrees. Now this one I see from like looking at for corresponding angles, like angle 1 is top left, so it has to match over here to top left, so they have to be equal. And angle 1 plus angle 2 add up to 180. So I know angle 1 plus angle 2 have to equal 180 because they add up to that straight line right there. Now I can look for corresponding angles over here. Well, 3 is bottom right, so it could be equal to the bottom right over here. And these two angles also add up to 180 degrees. So angle 3 plus angle 4 equals 180 degrees. So if we add all of this up, we do in fact get 360 degrees. So the answer should be D, it's all of them. Okay, so number 11, if an angle has a measure of 225, then what is the measure of that same angle in radians? So basically when you're converting with like radians, degrees, radians, it's some version of like using 180 in pi. It's just you flip-flop what you're multiplying by based off of if you're going to radians or degrees. So how I like to remember it is like radians involves a pi. So if I'm starting with degrees and I'm going to radians, I need to end up with something that has pi in it, right? So if I'm deciding whether I need to multiply by pi over 180 or 180 over pi, I have to think which one of those is going to give me like pi in my numerator. Like it usually, radians has like pi involved in the numerator. I don't know, this is just a helpful trick for me, so hopefully it helps someone else. So that means I'm going to have to multiply by pi over 180 to get to the radians. Because usually what happens is like people know that they have to do either this or that, but they mix up like when to do which one. So I like to think of radians as like pi in the top, is what I need to end up with. The only way to get that would be to do this, multiply by that version. And it's even more like obvious when you go and do the, what do you call it? Like radians to degrees, which I'll show you after what I mean by that. So all I have to do is multiply by pi over 180, basically, when I'm going from degrees to radians. And you want to just cross cancel whenever you can as well, to make your life a whole bunch easier. So 45 goes evenly into both of these. So it goes in 4 times into 180. And it goes in 5 times into 225. So now you have 5 times pi over 4, which is just 5 pi over 4. So the answer would be B. So now I'm going to show you what I mean by when you're going from radians to degrees for this one, how it's like if you remember that you either have to multiply by this or by that, and you can't remember which one it is for radians to degrees. It's even more obvious here because when you get to degrees, like you don't say like 2 pi degrees, like that's not a thing. Like we say 360 degrees. So you need to get rid of the pi that's in the radians. The only way to get rid of it would be to multiply by this, because then the pi's would cancel out. Because if you multiply by 180 over pi, that cancels, you see? And then the 9 goes into 9 one time, it goes into 180, that would be 20 times, so then it's just 12 times 20. And that should just give you 240 degrees. Okay, so now pause to read number 13 if you haven't already. So this is the setup of the information we've been given. The measure of angle B is 7 pi over 6, and then we are going to subtract 3 pi over 4 to get angle A. So let's make them have a common denominator. We can multiply by 3 on top and bottom here to get a common denominator of 12, and we can multiply by 2 top and bottom here to get that common denominator of 12 there. So this is going to be 14 pi over 12, and then this is going to be 9 pi over 12 equals, I'm going to just say angle A like this to save time. And then I'm going to subtract the numerator, so that gives me 5 pi over 12 is equal to angle A. So now I have to pay attention because it says I want the measure in degrees. So I need to convert this from radians to degrees. So that means I need to multiply by 180 over pi. The pi's will cancel out right there. And then 12 goes into 12 one time. It goes into 180 15 times. Ooh, that was a terrible 15. Rewrite that. And then now I'm just left with 5 times 15, which is just going to give me 75 degrees as my answer. Okay, pause to read number 14 if you haven't already. So we need to figure out what x and y are and then plug it in to get the value of this right here. So let's see. We know that this is an octagon because it has the 8 sides, and we know how to find the interior angle, like what one interior angle of a polygon is, with our formula that we know. If you're not familiar with it, it's on the formula sheet in, I believe it's chapter 4. But basically it's 180 times n minus 2 gives you the sum of all the interior angles. So then you just have to think, okay, well then I'm going to divide by n the number of sides in order, or number of angles and sides, it happens to be, but to get what the measure of one interior angle is. So like this top part is the sum of them, and then if you divide by how many angles there are, you get the number of interior angles. Or the measure, oh my god, I can't talk today. The measure of each interior angle. So there's 8, so we're going to plug in 8 for n. 180, and then times 8 minus 2 over 8. So let's see what that is. So that's going to be 135. So each interior angle in this octagon is going to be 135 degrees. So this is one of them that's 135, this is 135 degrees, and this entire part right here, that angle, these angles added up are going to be 135 degrees as well. So that means y plus 90 equals 135 degrees, and the same thing over here. X plus 90 degrees equals 135 degrees. So now, I mean, we know x and y are equal, so technically just find one and you found the other. So let's just do x. We're going to subtract 90 degrees from each side to get x by itself, and then we're going to get that x is equal to 45 degrees, which means y is also equal to 45 degrees. So I just rewrote it like that over there. What I'm going to do now is I'm going to rewrite this with the negative exponent rule to say that I'm really looking for, this would be the same thing as if I just put the y on the bottom to the positive one, which we don't write the positive one in the exponent. Someone just decided that in math one day, I guess. And just like we don't write it as a coefficient typically. Now what we're going to do is we're going to plug in what x and y are. So we could say it's 3 times, and I mean, you could probably try to simplify this further, but like you have a calculator available to you, so I would just do it like this. So 3 times 45 cubed over, and then it's going to be 45 squared. Ooh, that's supposed to be squared. And then times 45 again. So you would just plug that in, and then, I mean, I guess technically I could show how to solve it. I should probably do that just to be like a good math teacher, you know? So this is the same thing as 45 times 45 times 45. So I could take out a pair of 45s technically. So I could say that's 3 times 45 root 45. And then this is 45 times 45 times 45 on bottom. So I can definitely cancel out one of the 145 on top for one of them on bottom. And I could say, okay, how could I rewrite 45? Well, that's the same thing as 9 times 5. Yeah, that's the best way to rewrite it. Yeah, 9 times 5. So then 9 is a perfect square. So we can take out a 3 for that. So then it's just 3 times 3, leave the root 5 there. And then we're going to have 45 times 45. Now, 3 times 3 is just the same thing as 9. So I'm going to just say that that's 9 root 5. And then I can rewrite one of the 45s as 9 times 5. I could say these cancel out. So then I'm just left with root 5 over whatever 45 times 5 is, which that's just going to be 180 plus 45, so 225. Yeah. So then that's just going to be C.